further on up the road, play together again. Further on up the road, hang out with our friends. Further on up the road, play together again. Gotta take care of your brother, that old saying is true. Take care of your sister, that old saying is true. They both gotta know, gonna take care of you. Hey, all right, that's what I'm talking about right there. Old blues stuff. Put my guitar down. Is Mr. Pat yakking at you from the Boys and Girls Club, Windward, Kailua. There's another lesson today. That was an old blues standard. I think Bobby Blue Bland, kind of a hard name to say, wrote that way back when. Popularized by a group called The Band and by Eric Clapton, Joe Bonamassa more recently, Further On Up the Road. And again, we changed the lyrics up. We wanted to say thank you to all those folks. Then just do that to use it to get our message out for these times we're in. Taking care of each other, that's what it's all about. Okay, we're going to run a math lesson now. And today we're going to continue that division house stuff. This time going to be factoring, going to be focused on algebra totally. We're going to be factoring binomials. I forget what that is. I'll tell you in a second. And we'll go from there. And again, let me reposition my computer to capture the board here. And away we go. Okay, factoring binomial expressions. So, if you're in 8th grade, you were starting to get into polynomials, adding, subtracting. You were doing that kind of reverse FOIL, factoring trinomial things. So, don't be put off by the word binomial. It's just how many terms are in something. So, for example, a monomial, single mono, would be something like 10y. Okay, if I add something to it, so those aren't like terms, they can't be put together, that's 10y plus 6, that's a binomial, because there's two terms there. So that's all we're talking about today. Bicycle, 2 wheels, binomial, 2 terms. So what we are going to do is, yesterday we learned about the greatest common factor, how to find that using the division house. This is why you need it. You don't always use the greatest common factor because you can do things in steps, but when you're factoring something in algebra, you want to factor completely, they say. And so eventually you have to come up with a GCF of an expression. Okay, so before we actually do that, I want to have you recall something, because we're going to kind of go reverse of this. So remember something called the distributive property. Distributive property is a very important property used all over the place. Okay, we're going to do a couple of examples here. So we'll start with just the basic, no tricks or anything. So you recognize the distributive property is being used when you have a parentheses and a number outside of it with nothing in between here. So what's invisible there is a multiplication sign. And you are distributing that 7, multiplying that 7 to everything inside the parentheses. It can get tricky with negatives. We're going to not get too fancy with that. Leave that to your regular education classes to get you a lot of practice. You'll see teachers do this a lot. They'll draw arrows to remind you you're multiplying 7 times 4x, and you're also multiplying 7 times negative 9. So you're doing 2 multiplications. So you end up with 28x minus 63, or you can write it 28x plus negative 63. Hopefully that looks familiar to you. Okay, so I'm going to do another one. I'm just going to erase this so I can work right here. So that's about as basic as the distributive property gets. And again, it gets trickier with the negatives. You got to be careful, but let's do one more. This is an important one for what we do today. Okay, so I'm going to use a different variable, 3n, 8n plus 5. Okay, now this is very important here. So what I'm going to do is, instead of, well, I'll draw the arrow, but what that is 3 times n times 8 times n. Then plus 3 times n times 5. So these little times n things aren't written, you just see 3n. The reason that's important is when you're looking at this part of it, it's not 24n. 3 times 8 is 24, but it's n times n, so the power goes up there. A lot of people miss that. And then when you go this, it's not 3 times 5, it's 3n times 5, so it's 15n. So you got to be really sensitive and careful about powers going up. Okay? So what we're going to do today is we're going to go backwards. So we're going to start with an answer like this, and we're going to come up with something that looks like how this one started. So we're going to start here and end up here. Should have drawn my other arrow for that other thing. Okay, here we go. Let's do this. Factoring binomial expressions. Okay. So nothing like an example to get us started, so I will do that. So here's problem number 1. We are going to factor, let's see, let's do this. 36n squared plus 80n. And I'm going to use the division house to do this. So if you were with us yesterday, you saw this in action. What's going to happen is I'm going to come down here. I'm going to make a big division house. I'm going to put that whole thing inside, but I'm going to make one adjustment. Instead of writing n squared, I'm going to put nn. Okay. And then 80n. Okay, now if you remember yesterday, when we do this, we're going to deal with the numbers first. So you think of anything at all that goes into both 36 and 80. Okay. And just like yesterday, maybe what you see is 2. So 36 divided by 2. Remember, if you can't actually do that in your head, you can go like this, is 18, and make sure and bring the variables up. 80 divided by 2 is a lot easier. Most of us will know that's 40. Okay. So far, so good. Clean that up a little bit here. Okay, so now you look at 18 and 40, and that can be divided again. So I'm going to go like this. I'll just keep that same color. And I am going to, look at this, I am going to divide by 2 again. 9, bring the variables up. 40 divided by 2 is 20. Bring that plus sign up. So now you think you're done, and with numbers you are. So you have finished that. what happens here is you can take a variable out. So remember how we did this? There's an n here, there's two n's here. You have to take the same amount from each one, and you want to take the most possible. So the most I can take out is 1, because that's all I got over here. So I'm going to take an n out here and an n out here. Remember, you're dividing. Just like you divided 80 and 36 by 2, 40 and 18 by 2, now you're dividing by n. So you get 9n plus 20. So it's just like yesterday, but now what we're going to do is we're going to rewrite this thing. So I'm going to stop for a second. When you factor something, you are not changing the value of it. Whatever we write for our answer still equals that thing. It's just going to look different. So you're not changing the value of 36n squared plus 80, and you're changing the way it looks. And here's what you got to do. You have to take all this, okay, and you multiply it together, and you get 4n. That is the GCF. We did that yesterday, okay? So that is going to be what goes outside the parentheses. So the GCF goes right here every time. The secret to this whole thing is whatever is left over here goes inside the parentheses. So you have to remember to include this outside, and you remember to include that inside. And that is your answer. This thing right here is factored version of that. And what's a trip about all this is if you do the distributive property, 4n times 9n is 36n squared. 4n times 20 is 80n. So this equals that. It just looks different. And you're going to find in a whole lot of stuff that this version and we will do another example. Okay, you guys ready for this? Example number 2. Okay, let's go. 60 x cubed minus 48x squared. And we're going to factor completely. Okay, again, we're going to rewrite it. We want to have it completely factored, not be able to go down any further. So let's start. Okay, when you set this up, I'm going to strongly recommend you expand the variable part out. So I wrote 3x's multiplied together because it's x to the third. Notice this has a subtraction sign. And then 48x squared. Okay. So I'm kind of going a little slow. So you guys think whatever you know goes into these. So I always start at 2. Maybe I'll start at a different place today. Okay. Maybe I go, right, I know 6 goes into those. So let's say I start with 6. Okay, 60 divided by 6 is 10. Bring those variables up. Minus. From times tables, 48 divided by 6 is 8. Bring the variables up. Nice job. Okay. ask yourself if you're done. You might want to check right here and make sure you bring all the variables up. Sometimes it's easy to miss. We need another step. Do it all in black, this one, easier to follow. Okay, 10 and 8 are both even numbers, so I can take a 2 out. So I'm not done. That's an easy divide for all of us. The variables came up like they're supposed to. Might want to step back and check yourself. Divided right, brought everything up. Good to go. So now 4 and 5, done. Nothing else we can do with that. I got X's all over the place, so we got to think. So now what we're doing is we're looking, and we're going to see that I'm going to say it again just like yesterday and earlier. I want to take the most number of X's I can out. But whatever I take from one term, I got to take from the other. So this has 3, but I can't take 3 because that one don't got enough. So this has 2, yeah, I can do that. So I'm going to take 2 X's, X squared out. So I took 2 out of here, 2 out of here. Be careful you don't cross that one off too. You can write it like that, or you can write X squared. Okay, then what goes on top? I'm going to go ahead and put this in green. I want to make that kind of stand out there. Okay, you guys ready? What goes on top is what's left. 5x minus 4. So now I check. This has a variable, that one doesn't. 5 and 4 can't go down anymore, so I'm done. So now I finish. I am going to rewrite this. What I write has to be equal to this, but look different. And it's called completely factored. Okay? So what I am going to do here is outside. So here's your GCF. 6 times 2 times x times x. So that's 12x squared. That goes outside. So the GCF always goes outside. So I put 12x squared. And whatever is left over, as long as you did it completely, you'll have the right answer. Goes inside. 5x minus 4. And at this point, you can check for yourself. You can look and you can see, did I leave anything? Could I go more steps? Did I include everything out here? Yep. And then 12 times 5 is 60. X cubed times x, x squared times x is x cubed. 12 times 4 is 48, x squared. Minus. Check. That is completely factored version of that. So you're successful. Okay, nice job. I want to do one more before we close up for the day. This one throws some people off, so it's good that you see it. This is all algebra that pertains to everything. This is your normal 4th quarter curriculum thrown in 3rd or 4th at some point. Helpful for people. Okay, here we go. Example number 3. This is our last one for the day. You'll see why I'm choosing it. 15x squared, you ready? Plus 45x to the 4th. So write that down, start your house if you think you know how to do this. Remember what Mr. Pat said about expanding in variables? 4th power, a lot of x's to write. I know from my divisibility rules that anything that ends in 5 is divisible by 5. 15 divided by 5 is 3, and you know, bring the x's up. 45 divided by 5 is 9, bring the x's up. Good job. Count 2, yes, 1, 2, 3, 4, 1, 2, 3, 4, excellent. Okay. I know I got at least, I can still take something out of the numbers, 3 and 9. So I can divide each of them by 3. Okay. Now when you divide this by 3, this is what people do. It disappears. It's actually a 1. So you can write this, or if you want to, you can put the 1 there. Okay, let's say you didn't do that. I want you to watch what happens here. So check that out. So now you're like, what? Because there's an invisible 1. A lot of times people get confused by that. So what I'm going to do is I'm going to keep going because I got x's I can deal with. And this is where things get weird. Okay, so I can take, there's 4 here, there's 2 here. So I can take 2 out. Just like the last problem we did. I can take 2 of them out. Okay, so I'm going to put those 2 outside. But then people don't know what to do. If they never wrote the 1, then they don't know what to do. So I should clarify something. When you're dividing an x out, x divided by x is 1. These things are actually 1s. They just, in multiplication, they disappear. But you don't think it's 0 here. These are actually 1s, 1 times 1, etc. So what comes here is a 1, because that's all that's left. Nothing else is there. Over here is 3xx. So when everything disappears in multiplication, there's actually a 1 behind. It's not like adding opposites where it turns to 0. It cancels out, just like reducing fractions. Sometimes they'll do that to you. So you got to watch for that 1. I know this is just one example. I hope that didn't confuse you too much. Okay, so now we're going to put this out. So 5 times 3 times x squared. So that's 15x squared. That's our GCF. That's from 5 times 3 is 15, xx is x squared. Okay, and then inside the parentheses is whatever we got left. And again, instead of writing xx, I'm going to be sophisticated and do that. Okay. And now, once again, you can check yourself. 15 times 1 is 15, x squared. 15 times 3 is 45, x to the second, that's x to the fourth. Perfect. Plus sign, plus sign. That's the one right there. Okay, factoring binomials, you want to factor completely. If you stop one step too soon, you will have factored it, but it won't be completely. So you won't be able to do the things you can do. You'll get marked partial credit or marked wrong. So the GCF comes in handy because when all is said and done, you got to have that sitting outside. The greatest common factor will always appear outside, the greatest common factor of these 2 terms. So you can do it in steps, that's not a problem, but you got to pull it all together at the very end and present it the right way, or you won't be as successful in algebra. Okay, hope that was beneficial to you. Factoring binomials. Tomorrow we're going to do one more thing with the division house. My plan is to reduce fractions. You'll get to see this being used in that. We'll do some traditional ones along with some algebra ones. And hopefully that'll help you grow in that area as well. Okay? All right. Okay, back at it. See what we got here, if we can fire up Buddy Robertson and the band a little more. Further on up the road, we'll play together again. Further on up the road, play together again. Oh, we're gonna hang out with all our friends. Gotta take care of your brother, that old saying is true. Take care of sister, that old saying is true. And you gotta know, they're gonna take care of you. Further on up the road, play together again. Aloha, thank you for being here. See you next time. A little more music, a little more fun. Maybe have a lesson just on a little guitar playing, teach you some fretboard. Coming up, take a day or so break from the math. But for now, we're on it. Division House, reducing fractions tomorrow. Okay, aloha, bye.